So we don't. I think ideally this will be a more open forum discussion. I have a couple of sort of thoughts that I want to kick off with. There was a lot of talk this morning about tactile sensors, right? A lot of different designs. Almost every speaker presented something related to tactile sensor design. I'm sort of would like to get the panel's opinion on the relative state of those sensors as compared to the hardware design and the control. It feels like the way we're using them is so far from how a human uses them. You know, even for these tasks like classification, you see a lot of like prodding and poking tasks to try to identify an object. It's far less dexterous than what a human would do. We saw almost no control using these very beautiful vision-based techniques. So where are we as a field, and what should we be working on? How should we be using them? I don't know who wants to try to field that or get it started.
So I could start, or is Professor Lynch starting?
No, go ahead.
Oh, all right. So I would say there's a bit of a trade-off when you look at all the types of haptic and tactile sensors out there, like force torque sensings. You saw how we use that quite dynamically. Those are very simple signals that you can process very quickly. On the flip side, I think when you start looking at image-based sensors, you know, the complexity in processing that kind of data makes it a little more difficult, I would say, in being able to use it in a closed loop control loop. So yeah, I would say there's a trade-off in terms of like the complexity of the sensor and the signals and what do you ultimately want to accomplish with that.
Yeah, Carolyn, I'm very much on the same page, I think, in terms of there's so much reliance now on visual tactile sensing because it gives such a richness of information. But it does seem like you're then losing an opportunity to measure things at a high bandwidth. And I do wonder how that's coming into your system as well in terms of, you know, what sensors might you want to add to do some of these other behaviors you're looking into?
So we sort of got into tactile sensing reluctantly. Somebody mentioned earlier biotax, and we ponied up tens of thousands of dollars for biotax years ago and struggled with them to get them to do something interesting. And partly it was because we wanted to, know where contact locations were and what forces were and things like that. Whereas that's not really what they were best suited for, right? In fact, I think the people who've gotten the most use out of them are people who've paired them up with machine learning to just, see what we can get from all this data that we don't really understand coming in. So first of all, I'd say I'm very encouraged by all of the things happening in optical tactile sensing these days. I think, it's sort of, we're discovering all the possibilities, but we're also discovering the limitations. And one of them is what you mentioned, is that anything at high frequencies is kind of lost. On the other hand, maybe we can use, event cameras to do something at high frequency. So, I think it's just a very new area. And we still have a lot to learn, but it's clearly opened up new possibilities that haven't existed before. I would like to mention also that the original inspiration for our particular optical tactile sensor went back to the early 90s when there were early vision light waveguide based vision tactile sensors were introduced. So the idea is not really that new, but it's just in the last 10 years it's really taken off and people are starting to explore its capabilities. But for dynamic manipulation, I think maybe something with the event cameras will allow us to bridge that gap.
Just a follow up, but do you think processing time is really the limiting factor here? I feel like there's such a lack of dexterity as well in the design and the control. If I think about how if I wanted to do object classification, I would use these rich tactile sensors, but I would also sort of reach around an object, right? And I don't have one on me, but I would sort of grab it from different angles and I would move my fingers along it. And that feels totally missing from our current strategies.
Well, I think that, sorry, Ken, I was just going to say, I think Maria's work and Caroline's to some degree are addressing this idea of active sensing, where the challenge is to move the sensor to acquire information in a principled way. And this idea, this interaction between the sensor and the joints, that sort of feedback loop, I think is very interesting and is very subtle. I mean, humans do that, but it's very subtle to see how do you take a measurement and then use that to essentially guide the next measurement.
I agree with that. I guess I feel like there's such a richness to the sensor, what it's capable of, that we're somehow not able to exploit right now. And I think that's coming from the hardware, coming from the control. But maybe I'm in the minority.
Hello, so I'm Jingxi, and I have two questions. So I also work on tactile sensing. So my first question is about the simulation. So I know that nowadays a lot of labs are developing their own tactile sensors with very rich raw data. But I think a big problem that prevents the tactile sensing being used for complex manipulation tasks is the lack of good simulation. And I think one of the reasons for this is because if you look at the paper right now that use tactile sensor for manipulation, I think a good portion of them still like regress the high dimensional tactile signals into like location or contact or non-contact. And I think that one of the reasons is because we can't simulate these raw signals directly, so that we can't do zero transfer to like real robots. So that's my first question. I wanna ask, what do you think about like the status of simulation, and is there enough effort going into that? So my second question is about related to that is about standardization of tactile sensors. Like if you look at the vision, like camera, even though we have different camera, but they give like the images they give are standardized, right? It's RGB, dimensions are different, but they are like RGB images. But for tactile sensing, each lab has their own like way of sensing modalities. There is vibration, there's lights, there's a camera based. So they all give different outputs. So that also makes it hard to have a benchmark or like a communication between labs that compare different methods. So that's my second point on standardization of the tactile sensor design. Yeah.
I begin answering your first question, which was on the state of simulation of tactile sensing. So I am aware of some great work out of the NVIDIA Seattle Robotics Lab, along with collaborations with my lab mate, Isabella Huang from Berkeley. They've worked on using, speeding up sort of FEM modeling in simulation, which can be quite accurate, but very slow. And pairing that with a biotach sensor actually to try to learn this mapping of forces or the distribution of the forces over the biotach sensor to use more quickly with a robot. And recently, Isabella worked on trying to model tactile sensing with FEM modeling, and then speeding that up with deep learning to estimate stiffness and pressure distributions and force distributions over fingers. So I think sort of those directions make a lot of sense to me in terms of expanding the capabilities of simulation and relating tactile sensing.
Yeah, so I'm a designer, and so I'm creating these systems, and this is where simulation comes into play a whole lot, because it takes so much time to build a physical new system. So I think it's quite related to this tactile sensing question. And I think there is a role for more physics-driven simulations, but they are slow. And then maybe empirical models that are maybe closed form, you can calculate very quickly over a very large parameter space. I think probably there's a solution which combines them both, kind of as Carolyn was alluding to, except she was saying sort of going towards machine learning. I think there's kind of a couple different tools in this bucket. And it's probably a mistake to only use one of them, is my opinion.
Can I ask a question?
Hi. Can you hear me? Yes, it's good. Yeah. Hi, Alessandro Saccon. Now the question is that I had is seeing the presentation of this morning. I saw that there's quite a lot of indeed research and on these visual-based sensor, but I see at the same time, you know, the need of having a sensing capability over entire, you know, arms. And so I can see that is probably not a solution that you will envision, that is not the solution for that. So, and I know that there's quite a lot of research conducted, for example, on flexible electronics in these days, to be able to print really large area with a lot of sensing, and maybe then it becomes, instead of having a, you know, event-based type of cameras, you have event-based, you know, skin. You know, so I would want just to hear the comments. What is the trend there? And yeah, if you think that will be the future, at least for manipulation, where that requires area that are larger than just a fingertip.
Yeah, I think that's an excellent question. I mean, we have just started to work with some of, you know, fabric-based sensors. So as to say, I think there are many challenges still in terms of, you know, so if you take fabrics, for example, you know, what happens is, you know, fabrics start misaligning over time, which means that the signal to noise ratio is not as high as with the vision sensors. But I think, you know, there is a lot of good progress being made over there. So I think if you take gel site, for example, you can still have around 10,000 interactions and the sensor does not wears out. But with fabric based, I think that number is still around 10 to 20. So I think hopefully, you know, in coming years, you know, we'll be able to come to a stage where those sensors will become more useful.
I think someone raised their hand on Zoom.
Yeah. So thanks for all the great talks. It seems like a lot of the tactile sensing is very human inspired, in the sense that for humans, the sensing ability comes from mechanisms within our fingers or within our skin, nerves, and so on. And so those things are manufactured using light and cameras or gels and some other things. But I was wondering what you think about non-human inspired ways of tactile sensing. For example, could we use high resolution cameras and just look at minute deformations of things touching each other and get tactile sensing that way? Humans can't do that, but that doesn't mean that machines might not be able to do that also.
And so correct me if I'm wrong, but I interpreted this as a question of, you know, we take a lot of bio-inspiration in the design and control of systems. Are there solutions that are specifically not bio-inspired that we might want to consider in high contact scenarios?
Yes, and specifically for getting the tactile sensing. So it's all sensors embedded within the robot. But what if there could be an external camera that could give you tactile sensing?
I would argue, in fact, that this strength of visual-based sensing is not bio-inspired. Like, we don't have eyeballs under our skin watching what's going on. We actually have far less resolution. So I would almost say that our field is less bio-inspired in tactile sensing than it possibly could be. You know, I think some questions you brought up earlier about where do we want tactile sensing on the body? Like, what if you just had one sensor on your back that says your back is being touched? And that's very similar to the way that people sense things? I think this is a very interesting fundamental question. I don't know if there's a simple answer, but I am not sure that we're actually doing bioinspiration right now. Of course, there are good examples of it, though.
Yeah, I'll try and ask maybe one last question, moving towards some of the themes of sort of unintentional contact and bumping into things. You know, a lot of the tactile stuff that we looked at was very sort of slow, deliberate contact, and doing better job with that. What about sort of unintentional contact? And I know Kevin, maybe on the mobile manipulators, you alluded to this. Well, if you don't know the forces fast enough, then you have to have compliance. Have you have you done any work where where the human, I don't know, drives the object into the wall as it's walking, or any kind of unintentional contacts as it's moving, and how did it react?
Yeah, so in our case, that was the external disturbances. We wanted to have some compliance there. But yeah, right now, what I talked about is just all mechanical design considerations, but then how to plan for those potentials, it's not something that we've looked at yet. I don't know if that's getting to your point, but I guess fundamentally, I think we need to have compliance. We need to have physical, mechanical compliance. We can't just say, well, my Panda robot does impedance control, so I'm done, right? There's more than that. And more than that, I think it's important in some cases to have it well characterized, right? So that was kind of the reason that we developed our own fingertip tactile sensors, because we wanted to have a good characterization of how the visual data corresponds to forces in a way that we don't have to worry about hysteresis and other kinds of issues that come up with elastomers. So I think, mechanical compliance will always be necessary. Whether it needs to be well characterized or not, I don't know, but that's the way we're going, because we're trying to do a lot of things model-based. And if we don't have a good characterization, it's hard to have the model. I'd just like to go back to something earlier that we talked about, is what do you do with all this visual information? 60 times a second, you're getting multiple megapixels of data. What do you do with all that stuff? And one thing you could do is try to boil it down to, here's the contact point and here's the force. And then now I can use my very physics-based models to try to make progress. Or you could just throw all that away and say, I'm going to do end-to-end deep learning, and I'm going to figure out how this data this data should map through, some mapping that I've come up with, don't understand very well, but at the end I get good behavior. And how do I generalize? I don't know. So I think, a big part of the work going forward on using these tactile sensors effectively is going to be on how to take some stuff that we already know from models, how to bring in our physical modeling and combine that with, the data-based, data-driven machine learning kind of approaches. So